When you're graphing a system of linear inequalities, what you're doing is you're shading the graph like we've done before, but you're looking for where the shading overlaps. When we solved a system of equations by graphing, we looked to see where two lines intersected, but today we're looking to see where the shading intersects or where the shading overlaps. If you have two colors to do these, then that works really, really well. Especially like highlighters or markers, because we're looking for where the colors will mix. So if you're using markers, like your colors will actually mix, and where they mix is where your solution lies. So let's go ahead and graph these two just like we'd graph any old line. So I'm going to do my first line in red. They're already in slope-intercept form, which if they weren't, we'd probably want to rearrange it. My y-intercept is -5, so let's count down 5. 1, 2, 3, 4, 5. And put a point, and then since my slope's -2, I'll count down 2 and over 1 and down 2 and over 1. Or I can count up 2 and backwards 1 and do that as many times as I want to graph this line. That should all be a review for you. Remember, when we're graphing inequalities, we have to pay attention to whether we're using a solid line or a dashed line. Because our symbol was just greater than, we have a dashed line. So use a ruler or a folder, edge of a calculator to make that line as straight as possible. I don't have one of those for my iPad, so bear with me. I'm going to just freehand that line, do a better job than I did. But there's my dashed line. Make that go all the way through the graph. And then for the shading, my trick was I'm going to check the inequality symbol. Because it said greater than, that means above. So with your pencil on the line, draw straight up, above, greater than. So all that side of the graph is going to be what's shaded. Now, my advice would be to shade very, very, very lightly, because these problems can get really messy, especially if you're using markers and coloring really dark. So shade that entire section very lightly, or if you're like me and I can't shade lightly on the iPad, just go ahead, and I like to just put these little marks like grass sticking straight up, grass or hair or something, so that I know that that's the side that I would be shading, okay? At this point, switch colors to graph your other lines. Let's do red and green, make it festive and Christmassy. So that second inequality is still in slope-intercept form, otherwise I may want to rearrange it. So same thing as last time, let's graph our y-intercept, so it's +3. My slope is +1, so I'll count up 1 and over 1, up 1 and over 1. Or down 1 and backwards 1, do that as many times as I need to. Again, pay attention to whether you're doing a solid or a dashed line. This time it's less than or equal to. The or equal to is what tells me I have a solid line, so using a ruler, edge of a calculator, draw that line straight through. I'm freehanding it, but do a better job than I did. And now what you need to do is ignore everything you shaded already, because remember, your shading is going to overlap. So ignoring what's been colored before, this time I want to shade underneath the line because it says less than. So everywhere underneath that line you just drew, shade that very, very lightly. Or if you just want to do this and make it a little bit neater, I'm just going to draw little marks facing downwards to say that that's where I would be shading. Now at this point, you've divided your graph up into 3 sections. There's a section on the left, right, on the top and bottom. One of those 4 sections should have been colored twice, and if you've used markers, your markers have probably mixed together and made a new color. Otherwise, I can see that the section where both of those arrows, those little lines I drew, are pointing together is this section over here. So what I want you to do is now very darkly shade in that section. So make that really obvious. Sometimes people just scribble these and I can't tell where their answers are at. So shade that entire section very dark, make it very obvious that that's where your answer is. Any point we pick in that shaded section would work in both inequalities at the same time. So I get a visual picture for these. The picture is my answer. I don't get a single number for an answer. If you're not sure if I'm going to know where your answer is, I've had some people go so far as like to circle that section and then write something like, look, that's where the answers are. So if you want to do that, that's fine, but make sure it's very obvious where your colors have blended and where your answer is going to be. So that's what I'm looking for when we find the solution to a system of inequalities. And I've got a couple more examples if you want to see those as well. So in this case, notice my first inequality is not in slope-intercept form. So I'd probably want to go ahead and rearrange that first. So if you need help seeing that, I'll do that real quick. I'm going to subtract 2x from both sides. So 3y would be less than -2x. Plus 6, and then I'll go through and divide everything by 3. Keep in mind, if you ever divide by a negative, remember that inequality symbol flips around. So my new inequality in slope-intercept form would be y is less than -2/3 x, and then plus 2. So that's the first one I'm going to graph. Remember, do this in 2 colors. We're looking to see where those 2 colors overlap. So I'll do this first one in blue. My y-intercept is 2. And my slope is negative 2/3, so down 2 and backwards 3, and down 2 and backwards 2, 3. Do that as many times as you need to see that line. Pay attention to solid or dashed. This will be another dashed line because I'm not allowed to be equal to it. So draw that dashed line in. And there's my cat, if you can hear my cat meowing. And then I want to shade everywhere below this line. I want to be less than. So I'm going to shade very lightly everywhere underneath that line. Or just do these little marks if you don't want to make it too messy. Okay, switch colors at this point. I'll do green. The second equation, or inequality, is already in slope-intercept form. And what you may be noticing is you may have noticed the slopes, negative 2/3 and negative 2/3. Because both of those slopes are the same, these two lines are going to be parallel. Well, with a system of equations, parallel lines meant no solutions because they never intersected. That may or may not be the case this time, because remember, what we're looking for now is not where the lines intersect, they won't, but where the shading overlaps. So just because the lines won't intersect doesn't necessarily mean the shading won't intersect, but let's examine it and take a look at it. So I'm just plotting my points using my slope. Oops. Down 2/3. This time I have a solid line because I'm allowed to be equal to it, so use a ruler. So you've done a much better job than me, I hope, because my lines do not look very parallel at all, nor have I even gone through some of the points apparently, but you get the idea, I hope. And then shade this line. This time it says to shade greater than, so up above. So I'm going to shade above. And I can see that while I make this like gross bug millipede looking thing, there's nowhere where the shading did overlap. The blue line was shaded below and the green line was shaded up above. So in this case, I do have another example of no solutions. The lines don't intersect, but that's not why it's no solution. The shading doesn't overlap anywhere. That's why this is no solution. Okay, I'm going to show you one more example, this final one using three equations or three inequalities, and one of them happens to be an absolute value. So with this one, again, different colors work really, really well. So if you have three colors to use, that would be perfect for this. So let's go ahead and graph the top line and the bottom line first. So this line's a special line. It's a horizontal line because there's just a y in it. So same rules. Oops, horizontal. Same rules. I'm still going to do solid or dash and shade above or below. So this time it's y is less than 3, less than or equal to 3. So I'll count up 3 spaces on the y-axis and put a point, and I am allowed to be equal to that point, so I'll draw a solid line through there. And very, very lightly, because the 3 systems can get really messy, very, very lightly I'm going to shade underneath that line because I want to be less than. So shade everywhere underneath that first line. And let's switch colors and let's do our vertical line. So the x by itself is going to be a vertical line. So I'm going to count negative 2 spaces on the x-axis and draw a vertical dashed line through that point because this time I'm not allowed to be equal to it. And I'm going to break my own rule of, I've always said in class, like, don't think left or right of the line, think above or below. Well, this time we would shade below because it's less than, but I can't shade below a vertical line. So below just means, in this case, to the left, because that's where all the less than numbers would be, the smaller numbers would be to the left. And if I stopped there, the section that's been shaded twice so far is this region right in here. So my answer is going to be somewhere down there, but we have one more inequality to graph that will determine where in that section my final solution is going to be. So switch colors one more time. Let's go with purple, I suppose. No, that one looks too similar to the other color. Let's go with blue. So let's go ahead and do the absolute value one. Well, hopefully you remember to graph an absolute value function, you have a V or an A-shaped graph. The number inside the bars is going to be your horizontal shift. Remember, that lies to you, so it does the opposite of what it says, so it's going to move your graph to the left 4 spaces. Any number at the end would move your graph up or down, so there aren't any this time. So my graph is just moving 4 spaces to the left, so there's my vertex. I can use the A value, the number in front, to give me like the slope, sort of the slope of the sides. So one side has a slope of 1. The other side has a slope of -1, so I can count up 1 backwards 1 to get the sides of my graph. And same rules apply for solid or dash. So this will be a dashed absolute value graph because I'm not allowed to be equal to it. So I'll get that sketched in. And as far as the shading goes for this, for the blue graph, it says to shade my symbol says greater than, so I'd shade up above this graph, which in other words would be inside the graph. So I'm going to draw all these marks inside. So as you can see, the graph gets really, really messy really quickly. So hopefully you've shaded very lightly, or you've done my trick and just put little points. Well, the graph has been divided into several sections at this point. If I look carefully, though, I can see the one section that has been shaded all 3 times would be this little, almost looks triangular. It's not quite triangular because it gets cut off by that vertical line, but this little section in here. So make your final shading very dark, make it very obvious where your answer is. Otherwise, like I said, some people just go so far as to circle and say, look, that's where the answers are supposed to be. So just be careful with the 3. Make sure you're not getting too messy with them, because they can get kind of messy kind of quickly. But otherwise, just color and shade and look for where the shading overlaps. That's where your solution lies.